different structures. So the question is that among these two crack patterns that happens on after a major hazard to a structure, which one is more critical? The answer is that currently we don't know, but we're hopeful to do with the method I'm presenting, we would be able to do that. It's not working. It's not that the slide is not moving. It is to the different. I have to go back a little bit. Okay. So the question is, which crack pattern is more critical? Traditionally, the crack width was the main crack quantification parameter. When hazard hits the structure showed the damage in form of a crack. So it makes sense. When the crack is wider, it means more damage to the structure. But the problem is that I don't know if you can see it in the video because it has a little bit of delay. But under cyclic loading, which like an earthquake, when it hits the structure, it would push and pull the structure back and forth. So the width of the crack would change under these kind of loadings. I'm having a delay. When I hit this button, I don't know if it catched or not. Okay. Another problem is that human inspection is biased. This is an example. 49 bridge inspectors from 25 different US states. They were trained equally, but they came up with different results inspecting one single bridge. As you see on this graph, some of them are saying that the bridge is in excellent condition, and some of them are saying, hey, we should close the bridge and make some repairs. So this would lead us to the next slide, the need. We need a method with two major characteristics. One is that it has to have high automation capacity, and the other one, it should be unbiased. And with unbiased, we mean the method should be developed based on mathematics, not just the crack width. So here is the framework that average of all these edges. On the horizontal axis, we have drift. It is the displacement of the structure at each load when it goes back and forth, divided by the height of the structure. It is a standard way to report the displacement under each loading cycle. So the plot basically is showing that when the load increases and the structure reaches almost to the damage state, these average degree of net work also increases. We have the same graph for SW, this one was for SW1, we have the same graph for SW2 and also SW3. Since we had the images from both sides, I have plotted both of them together. So after that, we performed a Pearson correlation analysis. It shows us the features that we have extracted from the graph world. Is there any inherent relationship between the graph features, between the experimental ones that we have extracted from the test? So we defined a damage index, if it shows up. All right. The first part corresponds to the displacement. The more the displacement, it shows the structure has been more damaged. So the first term shows the displacement, and the second term corresponds to the energy dissipated at each load cycle. The more the structure dissipates energy, it has to show more crack patterns in one sense, and also it means more damage because it has dissipated more energy. So combining these two together, we have the damage index here, and here we have the graph features that we have extracted. So the first one is for SW1, we have SW2, and both faces of SW3. Here we can see there is a monotonic increase at each load cycle. So when the load increases, these graph features also increase. And the values here are comparable at the vertical axis. Most of them start from around 1.6 and ends with 2.2. And we see a high correlation. Most of them are above 0.7. So it shows us an inherent relationship between two worlds, and we can use these features for machine learning application. Moving forward, so we had the crack pattern. We converted these crack patterns to the graph features, to the graph representation, and only based on the mathematical representation of the cracks, we wanted to predict the damage index that has been acted on the structure. So to do so, we have the damage index here at the vertical axis. The more it is close to 1, it shows the capacity of the structure has been consumed. So the structure is more damaged in a sense. And on the horizontal axis, we have the drift, and we're trying to predict this ground truth using the graph features. So this is our prediction on the trained data, which is a very good fit to the actual data. So we try to make the model with the north face data, and fit this model again with the other side of the wall data, and both of them are showing a comparable trend with the ground truth. So it was really promising to us. And these are the results for SW1, SW2, and SW3 north face and south face. Regarding the errors, here the errors, the R2 square shows the accuracy of the model. We have the lowest one is this one, 0.934. The more this score is close to 1, it shows higher accuracy of the model. So to wrap up, in conclusion, successful conversion of crack patterns to the graph representation was achieved. There were high correlation between the graph features and the damage levels of the structure. We saw promising results regarding the machine learning application. And it showed that there is a high potential using this method in the mixed reality and unmanned aerial vehicles. The limitation was like limited experimental data. We are hoping to expand this method on more test data to see if they work. And at this point, less emphasis was placed on the image processing steps. Yep. In terms of future works, it is of our interest to explore the challenges associated with non-ideal surface conditions, colorations, and wet surfaces, examine different loading and design situations or other materials, investigate cracks caused by other reasons, for example, restraint shrinkage or alkali-silica reaction. At the end, I want to thank my advisor, Dr. Arvin Ibrahim, and it was a collaborative effort between University at Buffalo, Dr. Sina Basare and Pinar Okumush. And SW3, that part of the experiment was based on National Science Foundation funding. So, thank you very much for your attention. I will be more than happy to answer your questions.
Excellent. We have 4 minutes for questions. We'll start with the judges first.
Great presentation. I always think a hallmark of a good presentation is when the topic is something I've never thought about or doesn't generally interest me, and I listen and I'm enraptured through it. So great job there. I have 2 quick questions, and the first you already touched on a little bit. The sample walls that you showed were beautiful, smooth concrete, high visibility. What happens if it's brick or graffiti? And I know you mentioned that's a limitation. Do you have any foresight into what the AI model will do with that?
Thank you so much for that, for the question, bringing that up. This research has different stages. One of the stages is focusing on the crack detection, and it will be different between different materials, like if there is a brick or the surface is not ideal. Actually, there are other researchers focusing on that part to be able to detect the cracks even at the tiniest ones. And I mean, they're heavily investing on that part. So for that part, it wasn't the focus of this research.
Okay. And the second thing, I noticed you said, when you showed the amazing graph of all the different inspectors coming up with wildly different results, and you mentioned they've been trained the same way, has anyone given thought to redesigning the original training? Because clearly it's not working.
Again, that's a really good point, but I don't have any authority in that part. I hope that changes, but these days the trend of the research is going toward automatic inspection and trying to use the human knowledge only as the manager of kind of that system being developed. So this is the trend currently I'm seeing.
Thank you.
Yeah.
I also really enjoyed your presentation. I also not super familiar with the content area, but it was very fascinating and seems like an important topic. When you showed the graphs that compared your predicted damage index to the ground truth, the relationship between the ground truth for a damage index versus the movement, the x-axis, was like a perfect relationship. So is that just theoretical, or is that based off of experimental data, that ground truth?
Could you repeat your question? Which part?
So you're comparing to the ground truth line. Is that ground truth theoretical, or is the damage index actually that good at predicting?
Thanks. Thanks for mentioning. I should have referred to the equation that I talked about. The damage index. The first term was regarding the displacement, and the second term was energy dissipated. The ground truth was basically that coming from that equation.
Okay.
Yeah.
So is there a strong relationship then, like experimentally showing like failure of concrete or
yeah.
related to damage index?
Yeah. Actually, I should refer it to this way. That equation was from another another researcher that did like tons of experiments on different concretes, and came up with that equation, and it was heavily cited by different scholars, kind of attesting to the validity of that equation. So it kind of works. It shows that the more that damage index get closer to 1, it shows that the structure is more damaged.
Okay, great, yeah, that.
I hope that answers your question.
Yeah.
Thank you, you're at time. Thank you so much, Pedro. You can clap. Thank you, Pedro, for your presentation. Up next, we have Miriam O, PhD program in molecular and cellular biology and genetics, the Graduate School of Biomedical Sciences and Professional Studies, College of Medicine. Miriam?
It's not working.
No, it's good. It's working. Hang on.
Oh. Thank you everyone for being here today.
Okay, fine.
It's working. So thank you everyone for being here today. I'm Leon from College of Medicine. I study molecular cellular biology and genetics. And I'd like to talk about my research project about structural characterization of the long encoding RNA dogma. So there is a very fundamental concept in molecular biology called central dogma. And according to the central dogma, we have genetic information and messengers that carries that information, and then to produce the final functional product in our body. So if you can go back to the high school biology and remember, genetic information corresponds to DNA and messenger to RNA and the final functional product, protein. So once more, so we need messenger RNA or protein coding RNA to produce the functional protein. So the protein gets translated from mRNA or protein coding RNA because they are translated into protein, and there is a bunch of different types of proteins functional, which is are functional in our body, including enzymes, antibody, muscles, and hormones. However, there is unconventional RNA species called non-coding RNAs in our body, which are not translated into proteins. However, interestingly, they have functional significance, which is very exciting to all of us because so far we've learned and believe that proteins are the only functional product in our body. However, it is not true any longer because of the presence of non-coding RNA, which are functional in and of themselves. Just for a brief terminology, non-coding RNAs can be divided into 2 categories, including short non-coding RNAs as well as long non-coding RNAs or link RNAs, which are my research interest. And again, interesting fact about non-coding RNAs, among the total number of RNA transcripts in our body, mRNA or protein coding RNA only accounts for 4%, and the remaining majority of 90% of RNA species are actually non-coding RNAs, which suggests the biological importance of non-coding RNAs. So I know this slide looks a little bit busy, but I what I want to emphasize here is the fact that non-coding RNAs are functional and do play an important role in our body. So all those different types of link RNAs are misregulated. When they are misregulated, they can cause serious diseases in our body, particularly cancer, as we see here. And also link RNAs are related to different processes in our body, including aging process. That brings us to study link RNAs in general. And our group's approach to study link RNAs is to look into their structure, because for every type of biomolecules, their shape or structure matters a lot. So here we have an interesting example of protein. So we have this molecule here called kinesin, and they are water protein in our body, and they're doing their function perfectly. So with their 2 hands for cargos and 2 legs for walking along the cellular highway, they can deliver this cargo to wherever in our body that it needs to be delivered. So, and again, there's another example of misfolded proteins or unstructured protein. Yeah, those proteins are the protein species that fail to fold into proper structures in our body, and they can cause diseases, including Alzheimer's as well as Parkinson's diseases. So, all these examples emphasize the importance of structural studies of biomolecules in our body. Sorry, it's delayed. We can see that there is the studying the structure of biomolecules are super important for a better understanding of their function. So here, similar to proteins, sorry for this. Yeah. Similar to proteins, link RNAs fold into complex structures that relates to their function. And our group believes that the structural it's evident that the structural studies of link RNAs may also elucidate how they function in our body. So again, folded link RNAs are only functional product in our body, and here are different types of visual representation for showing how they are structured in our body. And interestingly, here we have the partial RNA structure of SARS-CoV-2 or COVID-19 viral RNA, which means that, yes, we do research into their structures for a better understanding of the disease mechanism in our body. However, unlike proteins, not many structural studies on link RNAs have been conducted today because the field of link RNAs is relatively new. Therefore, we have a lack of structure-function relationship studies of link RNAs. That brings us to study the notorious link RNA called SHLOP1, which promotes prostate cancer. SHLOP1 may actually drive progression of multiple cancer, including breast and ovarian cancer. However, its association with aggressive prostate cancer has been a major focus. So here we do have 2 different mice groups, with one group here with higher SHLOP1 level, and this group of mice have a lower level of SHLOP1 expression. And when we compare this colored area suggests the size of tumor. This group with higher expression level of SHLOP1 shows a higher level of cancer, which means that SHLOP1 really promotes aggressive cancer. However, the question of how still remains unclear, and we need to figure out the how question. So, prostate cancer is the most common cancer in American men, and also the second leading cause of cancer death. So about 1 in 8 men will be diagnosed with prostate cancer during his lifetime. We would say that prostate cancer research is very important. So for prostate cancer, early detection is extremely important because most men diagnosed with early stage prostate cancer do not die from it. However, it can become a serious disease if it is caught at advanced stage level. So for example, 5-year survival rate of advanced stage prostate cancer is only 30%, and additionally, as many as 30% of patients relapse after 5 years. So far, we have prostate-specific antigen or PSA blood test for detection of prostate cancer. However, it is far from perfect because PSA level, high PSA level, doesn't necessarily mean that you have cancer because PSA blood level can be higher for lots of different reasons, including simple urinary tract infection as well as even recent vigorous exercise. So yeah, early detection of prostate cancer is extremely important. However, at the same time, extremely challenging. So interestingly, for these circumstances, we have SHLOP1, which can be used for early detection of prostate cancer, because here, based on previous research, the red bar suggests higher SHLOP1 expression level, and higher SHLOP1 levels are related to a higher percentage of metastatic or aggressive diseases, as well as biochemical recurrence, as well as death from any cause, and from prostate cancer. So a higher SHLOP1 level is significantly prognostic for aggressive prostate cancer. Therefore, further development of SHLOP1 as a potential biomarker for aggressive prostate cancer is needed. However, the key question of how is still remain to be seen. So we know that SHLOP1 has potential as a novel biomarker for aggressive prostate cancer, but the key how question is still being uncovered. And we know that linked RNA structure is crucial for its function. Luckily, to our group, no structure studies have been conducted to date. So we strongly believe that our first structural study of SHLOP1 may elucidate its mechanism of action, providing insights into developing SHLOP1 as a novel target for prostate cancer therapeutics. Yeah. So, yeah. As I previously mentioned, linked RNAs fold into complex structures. So here we have our experimental strategy to determine the structure of SHLOP1 called shape map. And for a brief background, linked RNAs fold into complex structures by base pairing. So to make this complex structure, first we need to start from this string-like RNA structure. So there is 4 different base or ingredients to make this string-like RNA structure first. And they are base paired together. A base gets go together with U base, and G base go together with C base, and gets base paired or coupled, as we see in the case of origami, when those 2 corners go together, and they are folded together to produce this more complex or secondary structure. And as time goes by, these 2 areas interact with each other by long-range interaction. Finally, they can be folded into the final 3D tertiary structure. So all in all, base pairing equals to structure. So again, here's our strategy to determine the structure of SHLOP1 shape map. And we are adding RNA marker. They are just chemicals. And when we add RNA marker to our RNA, those chemicals attach to unbase paired region or unstructured region corresponding to a high shape reactivity. So here, high shape reactivity or modified region corresponds to unstructured area, And here unmodified region for low shape reactivity regions such as structured area. So our group got this shape reactivity map, and based on this result, we successfully built secondary structural model of SHOP1 here. And as I previously mentioned, areas with lower shape reactivity corresponds to structured area, and the remaining areas with a higher shape reactivity corresponds to more like unstructured area of SHOP1. And as I previously mentioned before, there is a different type of visualization for link RNA structure in general. So here in this area, in a much more zoomed view, the RNA looks like this. These two areas separately, this area corresponds to this visualization, and this area looks like this in our body in more detail. So once more, these structured areas of SHOP1 are very closely related to its function and very essential for its function. And again, for other interesting facts about this area, SHOP1 structure has not been changed throughout evolution over 10,000 years or more. When we divide SHOP1 into 5 different segments here, the blue area, especially this area and these areas, turn out to be highly remained unchanged throughout evolution, and in more detail, more than 50 vertebrates share the same structure of SHOP1. So, which suggests that unchanged structure strongly indicates its functional importance. So, all in all, our group identified the structures of SHOP1, and structured areas of SHOP1 are essential for its function of promoting aggressive prostate cancer. For future direction, ultimately we are attempting to determine the tertiary or 3D structure of SHOP1 structured areas using cryo-EM. And also we are attempting to identify direct protein binding or biomolecules in general, as well as their binding sites on SHOP1. So our group's research is unique in that we are the first to study SHOP1 using structural approaches, and also the first to find direct interacting biomolecule partners of SHOP1. And for broader impact, this work will offer broader insights into the structure-function relationship of SHOP1 and its role in prostate cancer. And ultimately, this work has significant public health implications in that SHOP1 could be a novel target for prostate cancer therapeutics. So with that, I'd like to thank my lab members and my advisors for all their support and guidance. And thank you for your attention today. And with that, I'd like to open the floor to any questions.
Thank you. We have 4 minutes for questions. I'll start with the judges. Any questions you may have?
Yeah. Excuse me, sorry. Great presentation. Sounds like very interesting work. So I have a few questions. So in your introduction, you presented some pretty compelling evidence that the SHOP1 gene is, that it's related to how aggressive prostate cancer is.
Mm-hmm.
Is it only related to how aggressive it is, or does it also play a role in the development of it, or whether or not somebody gets prostate cancer in the first place?
Actually, the gene, the SHOP1 link RNA cells are only expressed when you have metastatic or aggressive prostate cancer. So it can be a super helpful indicator whether you will develop metastatic or aggressive cancer in general. So if you don't have prostate cancer of that advanced stage, you don't have SHOP1 expression.
So does everyone who has prostate cancer have expression of SHOP1, or are there cases where
in only the cases when you are going to have advanced stage prostate cancer.
Great. And So now that you have learned quite a bit about the structure, you said one of your next steps, I believe, was trying to identify like molecules that bind to it, presumably to like work towards like medicines and things like that, or medications, treatments for prostate cancer, I would guess. Does the structure itself give you, do you have any insights into like likely candidates that, based off the structure, or is that kind of just a guess and check process?
Yes, there we have, and kind of, we are living in the area of AI technology. So yes, we do have some prediction system based on the structure to predict what kind of protein or nucleic acid binding partners there may be. But they're such an early stage, so they are not accurate at all. So we have different experimental techniques for catching those direct binding partners in our hands. So yes, we can predict binding partners using computational method, but they're not accurate at this point.
I have about a minute and 10 minutes left, or 10 seconds left. Do you have a question? I just have one quick question. So, great presentation. The link RNA shop one, if you were to create a diagnostic test, I'm curious as to the scalability of that test in terms of cost administration. Is there already a diagnostic test on the market that looks at some kind of link RNA?
Yes, yes, again, the field of link RNAs is still emerging, so there's not many drug targets developed as very promising or FDA-approved drug for link RNA species. However, we have one prostate cancer-related link RNA approved FDA drug, not SHOP1, but the other link RNA. So we are studying SHOP1 for developing it as a novel therapeutic target. It seems very promising, but yes, the field of link RNA is still very.
Very cool, thank you.
Thank you, we are at time. Thank you so much, Minhan. Lastly, we have Emerson Rowe, MD program in the College of Medicine. Emerson?
All right, good afternoon, everybody, and thank you for joining me. Is there any way I can get the notes pulled up on this screen? I was told that way right now. All right. So, science at its fundamental core, especially in medicine, is making sure that patients have the best possible outcome and are achieving their own highest satisfaction. So today we're going to be looking at a study that we did, analyzing the difference between absorbable versus non-absorbable sutures for closure following knee arthroscopy procedures. So what is an arthroscopy of the knee? As you can see on this image, the procedure involves 3 5-millimeter incisions that allow access to the knee joint for one, a cannula up on top, which is responsible for pumping fluid into the knee. Essentially what that does will expand the volume inside of the knee, allowing for ease of access for the other 2 instruments. The other instrument is going to be the arthroscopic instrument for the surgery, whether that's going to be a surgery type razor technique to remove cartilage, or on the other side, the actual arthroscope, which has a camera and a light source, which allows us to illuminate what's going on inside the knee. Now, just by a show of hands, who here has had any sort of arthroscopic operation on their knee? All right, that's pretty good. However, in the United States alone, there is an estimated 750,000 knee arthroscopies. If you take that into consideration, every single one of those 5 millimeters incisions is closed off with some sort of suture, and it usually includes 1 or 2. So on average, we're looking at about 5 to 6 sutures per knee arthroscopy. So when you put that in consideration with how many operations are taking place, we're looking at millions of sutures being used on knee arthroscopies alone. So which one is better, absorbable or non-absorbable? If you look at the current literature, there are significant differences that exist. In the setting of carpal tunnel and trigger finger releases, non-absorbable sutures had increased risk of what's called a dehiscence, which is when the suture site is actually reopened and usually has an increased rate of infection. In the total knee replacement, absorbable is superior to non-absorbable in terms of pain intensity, aesthetic result, and the effective cost. Notice how we have one type of procedure that favors non-absorbable and the other type that favors absorbable. But what about the knee arthroscopy, which is better? As a matter of fact, knee arthroscopies have scarce to any literature on whether or not absorbable or non-absorbable sutures is preferred. So with that in mind, the purpose of our study was to create a simple and elegant, single-blinded study to evaluate the outcomes and satisfaction with the patient's best interests in mind, and that is going to be for any sort of arthroscopic portal closure with absorbable versus non-absorbable sutures. So our inclusion criteria, to start off, the patients needed to be above the age of 18. That way we are eliminating any sort of non-mature bone. Also, we're looking at any sort of primary knee arthroscopy procedure, like a partial meniscectomy, which is just a removal of part of the meniscus. The chondroplasty, which is shaping of the cartilage inside of the knee. Removal of any loose bodies, such as cartilage or bone. And a synovectomy. And that's just the removal of the synovial tissue. The reason why we are including those 4 types of procedures is because they are almost equal in terms of inflammation produced per procedure and can be controlled for all of our patients. The exclusion criteria, we included any sort of concomitant ligamentous procedure because in order to make sure that we are having consistent amounts of inflammation present, we want to have a single type of procedure being done within the knee at all times. Any sort of meniscal repair, the meniscal repair is different from a meniscectomy. Instead of removing the meniscus, you'll actually be trying to fix it. Therefore, you are leaving exogenous materials inside of the knee, which can increase the amount of swelling and inflammation. And then any sort of revision arthroscopy, because we don't want to be measuring scar sites or wounds that are already present on the knee. Now, if you take a look at our inclusion table here, we started off with about 351 patients. After randomizing the absorbable and non-absorbable groups and losing 77 to follow-up, our final analysis included 274 patients, 145 were inside of the absorbable, and 129 in the non-absorbable. In terms of data collection, patients were contacted at 2, 6, and 12 weeks post-op in order to complete a visual analog scale, or VAS, and it's also going to be a visual analog scale that looks at the cosmetics of the scar, a 10-point visual analog scale for pain and patient scar assessment, and then a custom survey which we created to assess their satisfaction with the scar. Additional demographic information was included, including age, sex, BMI, race, and smoking status, and these were all controlled for within the 2 groups. Smoking status was especially included because it's well known that smoking increases the risk of dehiscence, and it also hinders the wound healing ability. So we wanted to make sure that we could control for that. Lastly, for statistics, we used t-test to compare data and chi-square test to compare any of our categorical data. The threshold for significance was set to 0.05. So here are some of those surveys that I was just talking about. Over here in the far left is the pain and scar assessment visual analog scale. So that first question includes current level of pain. And you can see how it's matching with the actual visual analog scale. So 10 being the worst pain imaginable, 0 being all hunky-dory. Over here we have rating your overall satisfaction, where 10 is extremely satisfied and 0 being not satisfied at all. Then we have satisfaction with the procedure, the removal process, and down here is some more of the categorical data where we ask patients just to state whether or not they had any itching, numbness, incisional pain, or burning. Up in the right is the scar assessment which we created. So is the scar painful? Is there itchiness? Is the coloring different? We're expecting to see some coloring just because of the nature of the procedure, bruising. Is the scar stiff, thickness, is it irregular? And we'll add this up for a total score assessment, which we compare among groups. And then lastly, the cosmetic visual analog scale. We essentially told each one of the patients to mark down on this scale line where they feel the visual appearance of their scale aligns. 10 being severe, that they don't like it, they see way too much of the scar, it's crazy. And 0 being no fine lines are seen and the scar is pretty much immaculate and it's a perfect incision. So our results, before looking at the table, interestingly, in the categorical data looking at itching, numbness, incisional pain, burning at any point, there was no difference at all. So we can say confidently that both the absorbable and non-absorbable groups provided great outcomes. So that's awesome. But now, let's take a look at our table. If you see here, we have some significant values, and this is interesting because we had higher overall satisfaction at 6 and 12 weeks post-op using non-absorbable sutures. So here's our non-absorbable column. You can see that compared to the absorbable, we had higher rates of satisfaction. Okay? Also, in the non-absorbable group, you will see that skin discoloration was also higher at 2 and 6 weeks. So you heard that correctly. Despite the non-absorbable group seeing larger rates of discoloration at weeks 2 and 6, they reported higher rates of satisfaction in the 2 later reporting times. Now this is interesting. After postulating what could have gone on, what makes the non-absorbable group higher satisfaction despite having worse visual analog scale scores, we postulated a few hypotheses that maybe weren't queried for in our surveys. So the first one, do the patients have a familiarity with wound healing that affects their satisfaction? If a patient understands the process behind healing, knowing that usually the bruising gets worse before it gets better, they may have a better understanding that, hey, just because it's getting darker, I know that the bruise is about to go away because of that. Or does the time spent with the doctor perceive as better treatment? Because the patients who had non-absorbable sutures had to spend longer times with physician and they actually had to have their sutures removed, this may have influenced their rates of satisfaction. Or let's take a look at the other group now. Was there frustration with delayed resorption of absorbable sutures? The absorbable sutures go underneath the skin, and then usually they're closed over the top with some sort of skin glue. A lot of times, because of the body's natural reaction to the absorbable suture, you're going to see a larger inflammation rate due to the use of the body having to break down the suture on the inside. Additionally, if you have to use glue on top, it might not be as pretty as having just a regular suture on top that was removed at 2 weeks, and you're just left with the residual effects of having the sutures removed. And so in conclusion and in future considerations, the patients that were receiving non-absorbable sutures reported higher overall satisfaction than the patients that received absorbable sutures. And for future considerations, we would want to include those aforementioned outcomes, maybe scores like resilience, the time spent with physicians, and then the also, yeah, that was actually it. The time spent with physicians and resilience and the aforementioned factors that influence the healing process in future considerations in order to have a better understanding of patient satisfaction when using absorbable and non-absorbable sutures. Here are my references, and I would now like to open the floor to any questions.
We'll start with questions from the judges.
Another great presentation. I really like your focus on patient outcomes. So obviously before you studied, there had to be a decision whether to use the absorbable versus non-absorbable. So now that you have this information, that might help the surgeons make that decision. But before, were there any other considerations that played a role, like cost or like ease of use of one suture type versus the other?
Great question. I'm glad you brought that up. Most of the time, it is up to the surgeon's discretion. Most of the time, they'll have a preference, just based on terms of whether or not they want to perform another procedure on these patients, having to get them removed. If they want to increase the cost, because that is an outpatient procedure for them to come back into the office, so it does cost more money with non-absorbable sutures. So oftentimes, they will incorporate the physician and get their feedback on whether or not they want to come back for that secondary follow-up. But other than that, it's really just up to the discretion of the surgeon.
Very interesting presentation. So you had mentioned this was the first time that anyone has looked at this. I'm looking at your references because my question was, in similar studies, was there a similar outcome that was incongruous to what your hypothesis was? And it looks like there possibly was with hand surgery.
So, oh wow. I will now admit that I missed an entire portion that I was supposed to talk about, which I'm glad I have more time. I'm just going to go back to that slide really quick, because there's a reason why there was a difference in the procedures that I talked about versus arthroscopic. And that was that the method and the type of procedures that we were looking at were very different. So carpal tunnel, trigger finger, and total knee replacement are all considered open procedures because they require access to the joint. And so the inflammation process associated with each of those is so vastly superior to what you're going to see in a knee arthroscopy, they're almost non-negotiable. And so that's why knee arthroscopy is going to have an entirely different process that we have to look at because of the reduced amount of inflammation, especially with the total knee replacement. I don't know if you've seen what those surgeries look like, but you have orthopedic surgeons hammering away at the knee. You're creating massive amounts of hemorrhaging and bruising. So compared to a knee arthroscopy, where it's just a 5mm incision, you're only going to be looking at minuscule amounts of inflammation. So we don't want to compare those types of studies to this. We just wanted to bring attention to the fact that there are studies out there looking at open procedures. However, the knee arthroscopy would be considered a closed procedure, and you're looking at it from the outside using the arthroscope.
Okay.
Yeah. Does that answer your question?
It does, and mostly. So then are there other closed procedures that have looked at dissolvable or not dissolvable?
That's a great question, and off the top of my head, I'm not sure. That would be something that I should definitely look up. I'd love to get back to you on that, because I'm sure we have some information about that that wasn't included.
Okay.
Yeah.
Thank you.
Any additional questions?
Have you looked at the demographics of your responses and seen maybe, based off of sex, age, or whatever it is, any of the other factors that you looked at that you, are there any other things that you can tell us? If non-absorbable was higher rated on certain age or weight or BMI or anything like that?
Good question. We did not look at that, but that would be definitely something worth mentioning, especially in studies going forward where we start to look at other types of procedures. I appreciate that. Thank you.
Questions from the general attendees?
Thank you so much.
Thank you.
Thank you, Emerson, for that presentation. And so with that, that is the conclusion of our program. Thank you all for joining us. A special thank you to our presenters for taking the time to share their expertise. And a big thank you to our judges for being with us today. Join us at the Basone Research Enterprise Center to support your peers, showcasing their 3-minute thesis competition presentations, and that will be in Mitchell Auditorium. Have a great day and enjoy the rest of the conference, everyone.